So now that we've talked about the common fork join pool and we've talked about ways you can configure it, let's demonstrate how you can configure it, and you'll get a chance to see the benefits of configuring it. So this particular example is available in my GitHub repository in the EX20 project, and this will illustrate how using some of the configuration techniques for the fork join pool, the common fork join pool, can help improve its performance. So we talked about a couple of different ways you can control the common fork join pool size in a previous lesson. This particular example here is going to show how to do it by using the ManagedBlocker interface. And ManagedBlocker is used in conjunction with a cool mechanism that's available in the common fork join pool that allows it to adaptively add new worker threads to the common fork join pool when the fork join pool divines that blocking is going to be taking place. And we'll talk about how it divines that. It divines that with the help of a special hook method called block that's part of something called a ManagedBlocker interface. So here is actually the snippet of code we're going to look at. We're going to look at the example in more detail in a second. But basically, there's a method called test_download_behavior, and it's passed in a function. And this function parameter, as we'll see, is used to pass in different strategies for downloading and storing images from remote websites. Not unlike part of your assignment, but a little bit different. And we'll see that there's 3 different ways it does this. And this is, of course, a good example of the good old gang of 4 strategy pattern. We can strategize the means by which we download and store images. So this method is strategized by this function that takes in a URL and returns a file to a stored image. When we run this program, you may see slightly different behavior because I'm using a different computer this time and we're over a different network connection than the last time I ran this. But what you'll probably see is that the default behavior, which downloads and stores images using only 12 threads, or in this case it'll be 10 threads because this is a 10-core computer, it'll execute slower than the other approaches that are going to end up creating more threads because they're going to adaptively create new threads. So that's the key theme to take away with from this demo we're about to look at. And this is the actual demo code here, again, in the EX20 folder. So we're now in the IntelliJ project for the EX20 example. As you can see, this will show how to use Java parallel streams, both with and without the common fork join pool's ManagedBlocker interface. And the goal of this will be to download and store images from a remote server. So it'll take a little while to do that. So I'll go ahead and start that running in the background, and we'll look at the program. So you can see here that there's a main entry point, as always. It parses the command line arguments, if any, and then it runs the test program. Here's the run method. It prints off how many cores the system thinks are available. In this case, it'll be 10, because I have a 10-core non-hyper-threaded MacBook Pro. First thing we do is we warm up the common fork join pool just so that the results will be more consistent. And then we run 3 tests. We run one test that uses this method reference to download and store image, which does not do anything special with respect to adding new threads to the common fork join pool when they block. The next one we're going to use is one called test adaptive MB for ManagedBlocker download behavior, and that codes the ManagedBlocker directly into the implementation, which you'll see is a little crufty for various reasons having to do with the way in which the interface is defined. And then finally, we're going to use something called test adaptive BT for blocking task download behavior, which is a little cleaner, and it uses a helper class we'll talk about. So let's go ahead and take a look at the run test method first. So here's run test. And the first thing we do is we come in and we delete any images that are left over from the previous run so we don't perturb the results. We then garbage collect so that the program will start with a full slate of memory. And then we go ahead and test the download behavior with this particular function that's passed in, which again, as you saw a moment ago, would be one of these 3 different functions we'll look at in more detail. So time run, as always, times the amount of time it's taken to run this test, and we pass in the test name. Let's go ahead and take a look at test download behavior. That's really the function that's doing the work, or rather the stream that's doing the work. So we're going to go ahead and grab a list of URLs, and the list of URLs is defined over here in the options class. You can see I've got a bunch of URLs that we're going to grab from my website, and just a bunch of different images. This is where you can find them all. And this probably wants to be final, so we'll make it final to make the IDE happy. And so what we're going to do here is we're going to take that list of images and convert them, the strings, to URLs, collect them all together, and we'll have a list of strings that we get from all this stuff. So we take that list of URLs, we turn it into a parallel stream, and then we use the map intermediate operation to take the function and download and store each image. And that's the part that's going to vary. And then we go ahead and we terminate the stream and collect the results into a list using the Java 16 toList terminal operation. And then when we're all done, we print the statistics for this particular run. So now let's go ahead and take a look at each of the different implementations. The first one, which is the one that's kind of the default, just downloads the image. And here's what download image does. Download image goes ahead and calls a helper method, which will just go out to the URL that we pass in here, get an input stream to that URL, and then it'll read the contents of that input stream buffer by buffer and write it to an output stream. So we're basically just reading the contents from the URL. That's nothing too profound there, just a nice way to read content, get content from a URL. And then we go ahead and we store the image on the local device. And this is just a little method that opens up a file that's going to store the image on our local file system. And it uses a thing called try with resources in order to be able to write the image file that we downloaded to the output. So we go ahead and write everything, and it's stored, and that's what store does. So this is what the default behavior does. And notice the key thing here is this approach does not use the ManagedBlocker mechanism, the common fork join pools ManagedBlocker mechanism. And I should probably say again, common fork join pool. And the reason I say that is because the ManagedBlocker mechanism is only available on the common fork join pool. So that version will just do it without anything special. And that means that the pool of worker threads will not be expanded. And after the first n of them, where n is the number of cores, which in this case is 10, the first 10 images start blocking, nothing else will happen until one of those images or multiple of those images finish. So it's going to underutilize the CPU. Let's take a look at this other approach. This is called download and store image MB. And this approach is going to use the managed block mechanism on the fork join pool. So this works with the common fork join pool. And we make a new instance of ManagedBlocker. And this is basically what's called an anonymous inner class. It's an earlier Java mechanism. I think it's been around since the beginning. And we're going to override the block method, and we're going to call the download image method from within block. Before, we didn't do that. We just called download image directly. And what download image does in this particular context is it will block the calling thread, but it'll inform the common fork join pool that that's occurring, and therefore the common fork join pool will compensate by adding another thread to the worker thread pool so that other threads that want to run, that have images to download, will get a chance to run. So it'll expand the number of worker threads in the common fork join pool by using this block hook method, by implementing our logic in the block hook method. And then when we're done, we go ahead and take the image we downloaded and we store it. By the way, we have to do this somewhat sleazy trick here so that we can access something in the context of an anonymous inner class. You can't make changes to variables in anonymous inner classes directly. So we have to do this somewhat tricky, sleazy trick where we make a one element array and then we modify the 0th item in that one element array, and that works. We could do other things here with atomic references of various types too, but this works fine. So that's the second approach. Not very pretty, but it works, and you'll see what it does in a minute. The third and final approach here is called download and store image BT for blocking task. And this uses a little helper class we'll look at called the blocking task class, and in particular the call and manage block helper method on the blocking task helper class. And what this does is it takes in a supplier lambda, and the supplier lambda will download the image in the context of this call and manage block method. So here is the blocking task class. You can take a look at this and see how the implementation is defined here. And this particular implementation is described in more detail at this link. What this does, it's really quite clever. It has a static method called call-in-managed-block that takes a supplier, and when you call it, as we did right here, it goes ahead and takes the supplier and it makes a new instance of a nested inner class called supplier managed blocker, which is past the supplier. So let's go take a look at supplier managed blocker. So supplier managed blocker is going to implement the managed blocker interface for the fork join pool. Now notice before we had to implement this in a crufty way using an anonymous inner class, which was kind of messy and ugly. Instead, this time we're going to have a helper class that implements that interface, and it's going to stash away the supplier that gets passed to it. It's going to keep a field that keeps track of the result, and also another field that keeps track of whether it's been called already, it's done. And its constructor stashes away the supplier here in the field. And then the block hook method, which will get called back automatically by the common fork join pool when the managed block method is called, it turns around and it says, hey, supplier, please invoke yourself. So by calling the get method on the supplier, that will cause the invocation of whatever was passed in, which in this case, as you can see, is a supplier lambda that downloads the image at a given URL. So that'll go ahead and do that call, but in the context of a thread in the worker thread pool, the common fork join pool. We indicate that we're finished, and then we're done. And when the get result method gets called, it'll return the result that was downloaded in block. So if we come back over here, you can see what we do is we go ahead and we make ourselves one of these objects, and then we call the managed block method on the common fork join pool. This, by the way, is a static method call. And we pass in this managed block local variable that we allocated here. So this is a lot cleaner than the somewhat ugly anonymous inner class code we had to write there. And when we're done, we then go ahead and when that returns, we go ahead and grab the result that came back from it that was stashed away in that local variable. So that approach is a little bit cleaner. And the other nice thing is now we have this reusable class called blocking task that can be applied in other situations where you'd like to do something similar. OK, so those are the different ways that the methods work. And so let's go ahead and take a look at the run behavior. And as I indicated, as I gave you a preview, here's what happens if you look at the results. You can see that they each downloaded 42 images, except that the default download behavior only used 10 threads. That was the number of threads in the pool. Actually, there was 9 threads in the pool plus the calling thread. So there were 10 threads used to do that. And you can see that it took a little bit longer to do that because it wasn't fully utilizing the amount of processor cores that we had. It was only using it was calling 10 calls at a time, and when they were blocking, nothing else was going on. In contrast, the other two approaches that use the adaptive behavior with the managed blocker interface and the managed block method on the common fork join pool ended up having 43 threads instead of just 10, because there was basically a thread for every one of these things that was running. And as you can see, there's an appreciable difference in performance. It's about half a second faster, which isn't bad. And that's just demonstrating that those two approaches were able to take better advantage of the amount of processing available on the particular platform. And of course, your mileage will vary depending on the type of hardware you've got and the number of cores and the amount of memory and the speed of the network, et cetera, et cetera, et cetera. But this particular example demonstrates a nice speed up.